another video on series. In this video, the series is going to be defined in a different way. It's not an arithmetic series, but it's still a type of series, and it looks like this. And a lot of students think that this is the most scary thing. Oh, wait, that just go. Anyway, that they've ever seen, and they don't know what's going on with it really. Doesn't matter, does it? No. So what we're going to do is show you how to read this notation and understand what's going on. Okay? So we've got u(n plus 1 is un plus 5, comma, u1 is 4. Okay, what we're going to do is we're just going to take n. N is the nth term. First term, second term, third term, fourth term. And this isn't necessarily an arithmetic series, it might be, it's just a random series. So u1 is the first term. This little 1 down here means first, and the u sort of means term. We usually use u for a term. So u2, this would be term second, term number 2, the second term. And u3 would be the third term. And u10 would be the 10th term. So that's just in the list of the series, it is the 10th number that occurs, that's all. So u1, we're already told, look here, that just says the first term is 4. Yeah, the first term is 4. Okay, so our series is 4. Dunno. Okay, what does this thing say? Let's put n is 1 there. So this would say u1 plus 5. Yeah. Okay, well I know what u1 is. u1 is 4. So 4 add 5. 9. What have I found? What is this? Well, I put n is 1 there, so I need to put n is 1 here as well. 1 add 1 is 2. u2, I found u2, I found the second term. The second term is 9. Now, n plus 1, oh, so I can put that on, 9. So what we've got is un, that's the nth term, plus 5, nth term plus 5 equals is sort of the next term. Yeah. So n plus 1 term.
So it's not talking about like the nth term as in the last term like
no.
we were talking about in the arithmetic. It's just talking about a term n, and then we're talking about the next term.
So 6th term plus 5 equals 7th term. 9th term plus 5 equals 10th term. And 12th term, thinking about it the other way round, would be 11th term plus 5. So what we're saying is to get the next term, you add 5. So actually this is an arithmetic series, it turns out, doesn't have to be. So this says, if you've got a term and you add 5 to it, you get the next term. Exactly. So it goes up in 5. Now it's not very useful because, for example, say I wanted the 10th term, I've literally got to work out...
You've got to know what the 9th term is.
Yeah, you've got to, exactly. So you've got to go a long way forward. But, you know, anyway, that's all it's saying. So unfortunately, at the beginning, this is what happens when students read recurrence relations questions. Their brains scramble and they get all confused. But what's important is to remember that it's just exactly what it says. What it says is, the first term is 4. 1 term, add 5, is the next term. To get next term, add 5 to the last term. That's all it says. So it's quite simple, really. Let's have a go at this one. So this is a hard one, in the sense that, it's not hard, but it's hard in the sense that the first term is k. Yeah, it's unknown, So can you work out what the second term would be?
Well, let's have a think about what that actually says.
Yeah.
So it says that if you take the term you've got, 4 lots of the term you've got, let's just put the first for now, then you get the second.
Yeah, exactly. So that's when n is 1.
Yeah.
So if n is 1, then it says 4u1, 1 minus 4u1 is u1 plus 1, 2. So the second term is 1 minus 4 lots of the first one, is what that says.
So the second one is 1 minus 4 lots of k. Because we know that.
Yeah, so this is u2.
Yeah.
So the second term, if we were building them up, it would say k, comma, 1 minus 4k, comma.
Yeah.
What about the next one? What would the next
Okay,
one
so U3 is 1 minus 4 lots of U2.
Yeah.
That's what that first one says, isn't it? And we know that U2 we just found that goes in there. So that's 1 minus 4 lots of 1 minus 4k.
Excellent.
Which is 1 minus 4, minus times minus plus 16k.
Mm-hmm.
So, which is minus 3 plus 16k.
Yep.
So the third term is minus 3 plus 16k.
Yeah. So the fourth one, U4, would be 1 minus 4 lots of the third one.
Yep.
Which is 1 minus 4 lots of minus 3 plus 16k, which is 1 minus plus 12 minus 64k, which is 13 minus 64k, etc. And then if we did 1 minus 4 of them, we get the next one. So we did, here's our first one, U1, then 1 minus 4 of that is U2, and 1 minus 4 of these is U3, and 1 minus 4 of these is U4. We're going to just do that for now. Okay. So that's using this whole piece of information here, what the first term is, how to get from one term to the next. But then we're told that the second term plus the third term is 10.
You see, when I first read this, I balked because that's just so much information.
Yeah.
But if you treat K like just something you know you can manipulate, you get to this point, suddenly it seems quite easy, doesn't it? Because all it's saying is, well, U2, which is 1 minus 4k,
Yep.
plus U3,
Yep.
which is plus minus 3 plus 16k, is 10.
Yep.
And then it's just an equation in K that we can
Yep.
rearrange.
Yep.
So 1 minus 4k minus 3 plus 16k is 10. Minus 2 plus 12k is 10. So 12k is 12. K is 1.
Exactly. Easy peasy. Yeah. Easy peasy. It's not, it looks hard, it looks complicated, it isn't.
No.
Just do what it says. It's fine.